Welcome back to part 2. We left this function, we had determined its inverse, but then we were going to talk about domain and range. The domain, let's look at the function itself right here, that part of the function. The domain of that function goes from x to infinity, right? So it goes from 1, to infinity. The range is everything above 0. So that goes from 0 to infinity. Well, now look at the pink graph. Look at our inverse graph. Talk about its domain. It's going here from 0 to infinity, and the range is at 1 to infinity. It's everything greater than 1. Well, look what happened. Okay, these swapped, which makes sense because our x's and y's swapped. Okay, that's how we get the equation. If we write the equation, instead of y equals 2 times the square root of x minus 1, I'm going to write x equals 2 times y, the square root of, y minus 1. Okay, that's how we're going to get the inverse. We denote it with f to the negative 1. Okay, and that's not meaning a negative 1 exponent. That doesn't mean flip it and make a reciprocal. That's not what we're doing, but that does mean you can get the inverse. Now you need to rearrange this. Okay, you need to solve this for y equals something. So we need to rearrange it. So I'm going to get y by itself. I'm going to divide everything by 2, first of all. So I have x, let me put the red one down. X divided by 2 equals the square root of y minus 1. Remember, I'm trying to get y by itself. How do I lift the square root? You square it. So we square both sides. That gives me x squared divided by 4, you have to square the numerator and the denominator, equals y minus 1. I'm really, really close. So now, if I just move the 1 over, I have y equals, right? So y equals, or the inverse, you can write it either way, okay? That equals x squared over 4 plus 1. Do you need to get a common denominator and write it? No. You can leave it that way. Okay? Where the domain, sorry about that, where the domain is from 0 to infinity. Okay? That would be our answer. We're going to do another example. Our last part of the lesson, so we dealt with, is it a function? Does it have an inverse? Now let's talk about composition of inverses. The composition of inverses is true if you have functions f and g, if they are inverses of each other. For example, you write that down. So functions f and g are inverses if and only if you can make each one of them the composite of the other and they both equal x. So that's how you're going to prove it. You're going to have to prove and show that the compositions going both directions equal x. For every domain in the inside function. So this is true for every x in the domain of G. The composition of G and F is true for every x in the domain of F. Let's try that with this example. This is our last example. Here's function f, 18 minus 3x. Function g is 6 minus x over 3. Okay? We want to show that these are inverses of one another. So we need to show that you have the compositions of each one. We have to do f composition of g, which would be f of, and g is 6 minus x over 3. We have to prove that that equals x. Okay? The other one we have to do is g composition of f, which would be substituting the value, the f function, 18 minus 3x, in function g. We have to prove that that equals x. So now let's do the algebra. If I evaluate function f at this value here, I have 18 minus 3 times this, times the 6 minus x over 3. Well, that's going to give me 18 minus 18 plus, right, you distribute this 3 times x over 3 is just going to give you x. Well, look at there, the 18 minus 18's gone, it equals x. That worked. Let's evaluate this function. I need to evaluate function g at 18 minus 3x. So I have 6 minus 18 minus 3x over 3. Well, I'm going to split this up. I'm going to split this up into two different fractions here. So I have 6 minus 18 over 3, remember, and now this one would also be negative 3x over 3. Well, this value is 6. This value becomes just x, but remember this negative distributes. So we end up evaluating with 6 minus 6 plus x, because that negative of a negative becomes a positive. Well, look at there. It worked. Okay, we proved that these two functions are inverses of one another, because we were able to prove it with the compositions. Okay? You could have graphed them as well and shown that by graphing, but you can also show it by the compositions. Okay? When you come to class, we will do this last lesson for 6.1 and 6.7, and then we will get ready for the test on Chapter 1. Thank you. I'll see you in class.